Goedenavond Amsterdam. Bedankt dat je naar mijn presentatie bent gekomen. Welkom bij Null and Void. Everything about nothing in .NET.
Yes.
That could have crashed dramatically. Okay, this is what we're going to talk about tonight. If you're watching on demand, then pause it, take a look at the agenda. We have plenty to go through, so I'm going to jump right into it after introducing myself. Hello world, hello Amsterdam. I'm Stefan Pölz, I'm from Vienna. I'm a Microsoft MVP, and more excitingly, I am a JetBrains community contributor, and this is why I'm super, super happy to be in the Forge, where the development tools that I use every day to build other tools are created. So thank you very much for having me. Thank you very much, .NET Amsterdam. Thank you, everybody, for joining. I'm in Vienna, a organizer of another meetup, so should you ever be in Vienna, let's have a chat. I'm also a co-host of the To Code or Not to Code live stream that I host with a friend of mine. We mostly talk about Roslyn and compilers. So even though I talk about a lot of C#, we will also talk about Roslyn as well a little bit. I am a senior engineer at Sentry, where we build tools that help you find bugs and problems in your applications and help you fix them faster, as well as now with AI-based support, prevent errors from occurring in the first place. Now, me mentioning that, yeah, I use JetBrains development tools a lot. Let's jump right into Rider. All right, null and void. I'm going to start with void. Void is the nothing return type. Let's declare a method. And when we state the return type is void, well, we can't really return anything. Means this method returns nothing. Void can also be used in local functions. So let's define a local function. As well, void doesn't return anything. Void can also be used in lambdas. Let's pass an action here. Let's call our local function, in our static method with a static void lambda that also does nothing. And there is another place where we can use void in an unsafe context. We can have void pointers, which is a pointer to an unknown type. It's not a null pointer, it points to something unknown. Well, it can be a null pointer. So let's clear some numbers. Maybe we do a little stack allocation and allocate some numbers. Well, these days with .NET, we don't use unsafe code anymore. We just use a span and use collection initializers, and then let the compiler do the right thing. In this case, it will stack allocate that memory, and we are memory safe. And this is where we can use void. The thing is about void, did you know that this is actually a type? Well, we can't use system.void directly, but it exists. We get highlighting, and it says system.void cannot be used from C#, but it actually exists. Well, in some cases, we need it. Well, whenever we come to reflection. Now I have a little test here. We have here a record type. If you remember, a record type automatically gets deconstructor methods. An amazing feature that I use all the time is the IL view, which is, yeah, we get our code compiled to IL, then we can let .peak, I think, decompile it back to C# to get rid of all of the syntactic sugar. And we see that we also get this deconstruct method that we can use if we initialize a new instance of this record. We pass a number and some text. We can actually deconstruct it into something that looks like a value tuple, text and int number. We just assign this R to it. And I am doing, what am I doing wrong? Oh, it's the other way around. And now we can just use these as if they were local fields. And this is called deconstruction, which is enabled by this deconstruct method. Now, with reflection, if we get a hold of this type, we get this method called deconstruct. We currently only have a single method. You can also overload it. And we then get the return type of this deconstruct method. The return type is void. We can actually check if this is type of void. So we can get the type of void, but only via the C# type of void. We can't use system.void. But system.void indeed exists. If we go to one of my favorite web tools called, if zooms in very slowly, source.dot.net, we can browse the .NET BCL, also the Roslyn source code bases. I think also ASP.NET Core is in there. We can search for system.void, and there it is. It's unspeakable from C# code, but it actually exists. If you are in other tools, or just briefly, if you are on the go and you don't have Rider at your fingertips and want to take a look at IL code or lowered C# code, you can use some other online tools like sharplab.io. That does the same thing. It can run code. It can take a look at the lowered C# code, but also peek at IL code. And there is another tool in town, lab.razor.fyi. If you're on the go on your phone and quickly want to decompile something, you enter your code here. Also can get a look at the lowered C# and also peek at the IL code. Wonderful. So much for void. The rest will be about null and nothing. In Visual Basic, it's called nothing. All right, what is null? Well, we can declare ourselves a string. A string is a class, so that's a reference type, and instances of reference types, they can actually, well, since it's a reference and not the value itself, it can be a reference to nothing. So let's actually do that. Null. If we were to write default, the default of a reference type is null as well. So if we write null, or default is the same for reference types. Now let's do control write line. Try to dereference the text by accessing its length. And yeah, Webby Sharper engine already lets us know there is something wrong, and we will now run into the $1 billion mistake into a null reference exception. There we have it. Now this is a null reference. If I were set it to something, let's say Goedenavond, we should get 10 or 11 characters. Here they are, because it's now no longer a null reference, it's an actual reference to a string somewhere on the frozen heap, because this string, it gets inlined, and we now have a valid reference. What about value types? An int or an int32, that's a value type. Can a value type be null? No, a value type, hence the name, always has a value. Well, it can be default in the case of an int. When all bits, all 32 bits are 0, its value would be 0. And, well, we can't really run into a null reference exception with value types. What about nullable value types? They are available since C#1. We can add a question mark after the int. Now this is a nullable value type. Can a nullable value type, we can actually assign null to it, be, well, reference to null? We now actually see that we get two new members, or, well, more members, but two new properties, has value and value. And if we try to access the value of a nullable value type, which actually is null, we will get not a null reference exception, but instead an invalid operation exception. Because a nullable value type is kind of a lie. It sounds good, and syntactically we can assign null it, but the nullable value type is still a value type, and the value type can never be null. If we actually take a peek at the IL code under the hood, what is this compiling to? We see that this int question mark gets turned into a type, into a totally new type. It's a nullable, a generic nullable of T type that is wrapping this int32. So in other words, when you write in question mark, we get a totally different type. It's no longer an int, it's now a nullable of int. And this nullable of int has the members has value and value. So what we would need to do is do an if check and check if this text has a value. And if it does not, well, only then should we, oh, actually, no, it should have a value, right? And if it has a value, only then access it to not run into this invalid operation exception. But where's this invalid operation exception coming from? When you take a peek at the implementation of the value property, the getter, it first checks, do we have a value? And if we set it to default, we don't have a value. And then we throw the invalid operation exception. Because still, the nullable value type cannot be null. So it's emulating null. And we only return the value when it has been set to something. If we say default, it's actually the same because we get a default instance of this struct, which is, well, the default of a Boolean is false, hence it will not have a value. And the default of a value, the generic t, in case of an integer, the underlying integer of when I set a nullable value type to null, it's actually 0. But we have the additional Boolean to guard us against that. So how now do nullable reference types, what's the core of this talk, are about, added in C#8. Previously, we could only add for value types a question mark to get this new type. Now with nullable reference types, we can add a question mark after a reference type as well. Now currently, I don't have this feature enabled. We get a warning here. We need to enable this feature first. Now, if you do .NET New, any template, you will see in each and every template nullable enabled. So this is an opt-in feature because if you would update from C# 7.3 to C# 8, all of your code will emit plenty of warnings. So it's an opt-in feature for existing projects. And all of the templates use this per default. Now we can use the question mark. Now we could say we assign null to a string. And if we bring back the previous example of, my laptop gets a little slow. Oh, because I changed the project settings, it's resyncing. Trying to access the length of this text, we now get a warning, and this is one of the many nullable reference warnings. It tells us dereferencing of a possibly null reference. And we already know at compile time that when we run this may crash with a null reference exception. And there it is. And if we were to actually assign it to something valid, maybe afterwards, we set it to, well, empty string is not null, it's empty. And we no longer have a warning. And we are now safe to run this because we won't run it to a null reference exception. This static flow analysis understood what's going on. But as you saw, I need to enable this feature. What if I have an older type compiled in C# 7.3 or with a project that uses a newer language version but does not have this feature enabled? There are none of these annotations. The thing is about a string question mark, that's not a new type. That's not a nullable of t or something. That's still just a string. The question mark is just some compile time so-called annotations. We will take a look at this. There was a bunch of attributes that get added so that the compiler knows, depending on these attributes, if something may be null or is not null. But at runtime, there is absolutely no difference. It's more or less just a compiler feature or a compile time feature. So if we compile the type, I call it an null oblivious type. So this type has not been compiled with nullability in mind. We create a new instance. We try to dereference the instance. Let's again dereference the text. That's a string property and access the length of it. We don't get any warning. Everything seems fine, although I enabled nullable reference type in my project. No warning, yet still null reference exception. Apparently, the string text here let me restart some tools because they have forsaken me. German, we say reboot tut gut. Now we don't get any warning, but still we run into a null reference exception when dereferencing the string here. Well, it appears to be null. Now, well, we have nullable reference types enabled, so it should be fine. Let's switch to a type that was actually compiled with nullability in mind, which I call the null aware type. It's the same shape, but it has been annotated correctly with a question mark. This text, if we take a peek at it, annotated with a question mark, we know that this may be null. And indeed, we now get a possible dereference warning, and we already know at compile time that at runtime this may crash. Now this is about reference types. When it comes to null, we can also have refs by null. For example, let me define a local value type. I assign 1 to it and print it to the console. I could get a reference to this value type, which is sort of a, well, it's similar to a reference type, but not quite. It's kind of an alias. It's pointing into the location of where this value is. So we can say, let's declare an int reference, and we get a reference to the value. And now when we set something via that reference, and my tool has crashed again. There we go. If we assign something via that reference, it is as if we were to assign it to the value directly. So even though we don't assign the value directly, we still, I should have set it to something different, -1. We still reassign it because we mutate the location directly. Now there's also null when it comes to refs. We could say something, well, unsafe, null ref of int. We need to get a ref to it. Now this is a null ref. If I'm doing this, this would now throw again at runtime a null reference exception. In order to check if a ref is null, we can do unsafe.is null ref. We pass this reference by ref, and now we are safe. We won't run into a null reference exception because, well, this is a null ref, and we won't mutate it, so we now get the 1 without running into any null reference exceptions. Now this is not part. Oh, we actually do. Oh, because I should negate it. If it's not a null ref, then please mutate it. And if it's a null ref, don't. And there we go. Now this is not part of C# nullable reference types, but just for completeness, this is how you check refs for null. All right. Now I showed you that we can enable nullable reference types. There is a bit more when it comes to those nullable contexts. There's 2 different contexts. Let's define a little class. Let's call it our class. This our class will get a required string text that we mark not as nullable, and an optional string that we mark as nullable. Let's also define a constructor, maybe an empty one, and constructor that takes a text and sets this text here. Now we already compiled, now we have nullable enable in the entire project. When we have nullable enable on the entire project, it applies to the, well, entire project. We could also just say, instead of enable, we could also say annotations. If we say nullable annotations, we only enable annotations. So this enables the question mark and means the absence of a question mark that it's not nullable. But we don't get any warnings. The inverse is we can just enable the warnings. Now, we don't get any annotation. So the question mark is disabled, and no question mark means we don't know. But we only get the warning. So you could decide between, do you only want to be in a warning context or in an annotation context, or both? And you get both by just enable. Is usually what you do. When you want to differentiate, this is maybe when you want to adopt an existing project to be nullable reference type aware, then you may need this fine-grained solution to build up your library to be null aware. So we can not only on an entire project level, but we can also define this on a file level. So we can use the preprocessor directive nullable and have the same enable or disable, as well as we could just enable annotations and maybe disable warnings. So again, we can kind of, in a fine-grained way, enable and disable the context. And if we say nullable restore, this is now restoring the default project. The default project is enabled. So in this case, we would basically, these two would be kind of no-op. So let's be explicit with enable. We could now just say nullable. We want to enable the annotations, disable annotations, and then enable them down here again. So actually, no, let's just disable everything. Oops. Let's disable and enable again. So we shouldn't get this warning. I am surprised. I think if we do a .NET build, we wouldn't get these warnings because in this context, it's disabled. So yeah, you can kind of fine-grain enable, disable it. It basically goes from top to bottom and just observes these preprocessor directives. But if we have the annotations enabled, we can use question mark. And if we have them enabled, the absence of a question mark means not nullable. So let's create an instance of this, our class. I should use this more, yeah. Yeah, I'm using this way too little. And yeah, I would say required.length. Let's point it to the console. We don't get any warning because it's marked as not nullable. If we were using the optional instead, well, again, we would get the warning. The thing is now, in this constructor, we do not set this required property. Actually, I wanted to say required down here. Now this constructor, well, previously, if we don't set anything, both of the constructors say, hey, this constructor is not setting the property that is marked as not nullable. We need to set the property as non-nullable to something that is not null. Now the warning disappears here. But here, well, we don't do it. So we have actually a warning here. And this is part of the static flow analysis. The thing is about the static flow analysis, it's static and it's not dynamic. One powerful thing is we could now in here set the required one to something, and the static flow analysis. Oh, I should access the required one here. Yeah. The optional. Excuse me. So I set the optional here, and the static flow analysis understands that the optional here is set here, and everything is good. But what if we were to, let's define a static method. That receives an instance of our class and sets this to null. Sets the required one to null. Well, we get the warning now here because we try to assign null to required, which is annotated as being non-nullable. Now we get the warning here. Well, we could just ignore it by adding an exclamation point. That's the null forgiving operator. And now call this method, our class .method. We pass in this instance. And although we do set it here to null, we don't actually, the optional, right? We should set the optional to null. The static flow analysis does not understand, because it's not dynamic, that this instance is passed here, set to null, and then accessed here. So although we don't have any warning, we still get at runtime now a null reference exception. So the static flow analysis is powerful, but yeah, it doesn't look through methods and the flow, because this would be way too expensive and also way too difficult to do right. There would be many false positives, especially when it comes to multi-threading. So none of these static flow analyses are thread safe. There is another feature that got added in C# 11. We can now have required properties. So if I were to set this property to required, this now means that it needs to be set. Now, actually, we cannot compile here. We get an error because it's now enforced to initialize the required property to something. Well, again, if I assign it to null, this would violate the contract because required is marked as non-nullable. Let's set it to something, maybe the string null. And yeah, the warning now disappears. But what about this constructor? This constructor is actually setting the required property. If I were now to invoke this constructor, hello, we still can compile because it still thinks we don't set this required property. And for that, we basically, as a developer, we assign all of the required properties in this constructor, so we can help the compiler out by using the sets required members attribute. And now the compiler sees, okay, this constructor is attributed with sets all required properties, so I don't check for these anymore. And again, we are good to go. But be careful, we could lie. What if I don't set this required property? Well, we do still get the nullable annotation, but we can actually compile. So when you use some attributes, never lie to the compiler. Compiler trusts you. Now, when we have nullable warnings, if we run it, we may end up with a null reference exception. What if I would like to promote these warnings to errors? I could go to the CS project, or even I could also, let's jump to the file system. We can have something like the directory build.props that gets automatically imported for every project that are in the same or a lower file hierarchy. And this is usually when you have a big solution, you could just in this singular solution set nullable enable to, so set nullable to enable, so that you have nullable enabled for the entire solution or the entire projects in this hierarchy, in this repository, if you put it into the root. And in here, we could now say something like treat warnings as errors true. But now each and every warning is going to be an error. Even, it will take a while until it catches up. There we go, now it's an error, we can't compile anymore. But every warning now is an error. Not just the nullable warnings, also a warning, because I enabled quite strict, I enabled all of the diagnostics and analyzers, even if a local variable is never used. Maybe I only want to enable the nullable warnings as errors. For that, we can, instead of treat nullable warnings as errors, there's another property called warnings as errors, where we can now specify specific warnings that we want to promote to be errors. Usually it's a good practice to, because this would be overriding if we have a hierarchy of MS build. When you set a property, you are overriding existing properties. So it's a good practice to kind of use this syntax to copy what was previously in this property to the now overriding property and add additional stuff to it. For example, we could add CA2007. That's the only diagnostic ID I know, because this is about when you await a task directly without calling configure await on it. And we could also, there is actually a bunch of nullable warnings. It's I think like 10. I don't want to add all 10 here. So we could use the alias nullable, which now is enabling all the nullable warnings, promoting them as errors. And this should momentarily, when my slow computer catches up with recompiling and reanalyzing the solution, now only have the nullability warnings as errors. But yeah, the other warnings are still as warnings only. I will be removing this strict solution for now to enable the rest of my demos, because we will be producing a lot of more nulls. When it comes to the null to the null analysis, this is enabled indeed for every document that is not auto-generated. So if you have some generator, a source generator or some generator that creates a file, usually you have the auto-generated comment on top. This is actually telling Roslyn that this is an auto-generated document, and we don't get any nullable warnings anymore. Neither here nor there. That's because for auto-generated documents, the default is nullable disable. So when you take a look at source-generated code, usually you see auto-generated on top, and then immediately after nullable enable to still opt in to this feature. Another thing that Roslyn considers generated code is when your file name ends in something .g.cs or .generated.cs or VB for Visual Basic. There is a couple of more of these, but those are the more common that you encountered. So generated files per default is always disabled. Now, we placed a lot of question marks and also one exclamation point. So how does this look under the hood? we can write a little example. I prepared a class called class. It's a terrible class name, but it says what it is. There's even an analyzer warning if you use a keyword in a type name, but I disabled it. So I have a method where the parameter is marked as null, or as nullable. Then I have one where the first parameter is not nullable, the second one is nullable, and also some combinations with arrays. When it comes to arrays or generic types for that case, for this array, we see there is 4 different variations of question mark. This means both the array itself as well as every string element in the array are non-nullable because we haven't annotated it. The second one means the array may be nullable, but the elements, the string elements within it, are not. This one is the opposite. The array itself is non-nullable, but the string elements within it may be null. And the other combination of both the array and each element within the array may be nullable. Now, how does this look under the hood? Because I mentioned it's just a compiler feature. The compiler usually annotates members with attributes. So if we take a look at the lower C# code to get rid of the syntactic sugar, I will now search for question mark in here. There is no question marks because these question marks, when we have nullable, the nullable annotations enabled, they get converted to attributes. And we see two, the nullable context attribute and the nullable attribute. Nullable context attribute, so we see this is kind of a hierarchy. When something does not have an attribute, so when, in other words, if something does not have the nullable attribute, like this one, it will take the nullable context attribute from its closest parent. The closest parent to this instance method is the class that this instance method is contained in, and this nullable context says, now this one is taken. So basically this one is applied to here, to here, to here, and so on. But this one is overwritten by the 2 here. Now what do these numbers mean? If we have a 0, that means oblivious. We don't know. If it's 1, it means not annotated. No question mark. Non-nullable. 2 means annotated. There is a question mark. We see the second one has a question mark. Therefore, it's a 2. So this may be null. Now, analyzing this structure, when you take a look at the current element, and then if it isn't annotated, you go to the parent. This is quite complex structure. You could use this for one-time features, but it's very difficult to do this correctly with the hierarchy. This hierarchy exists as an optimization. If you would have a nullable attribute everywhere, on each and every member, on every property, on every field, on every method, and of any parameter of the method, of all of the return types, and so on, you would add a lot of these attributes, and your IL code, your DLL, just gets bloated. So this is an optimization to reduce them to a bare minimum, but it makes it complex to evaluate. Therefore, in .NET 6, a helper type was added. I mentioned these attributes are only per default only take effect at build time, but we can, via Reflection, also consume that at runtime. So I have a little example here where we use the nullability info context, which we can ask questions about the nullability. So we will get all of the parameter infos of all of the methods via Reflection. Then we will use the context to create for each parameter a so-called nullability info. We have this context as a container to do caching, because if we ask the same type, if we ask a nullability question for the same type twice, this answer can be reused because usually during runtime the nullability annotations won't change. And this nullability info now has members such as the read state and the write state of this member. Well, for usually that's the same. For properties, it can be different because properties can have scatters and setters, so the read state and the write state may differ. We also have element type. So if it's an array, we know the nullability info of the element type. not the array itself. And also when it comes to generics, we may have many of these nullability infos. And this nullability info state, again, is super, super similar. It's either unknown, that's the 0. It's not null, not annotated, that's the 1. And it is nullable with a question mark annotated if it's a 2. And we basically now read this info and print it to the console. And if we take a look at it, basically we have here a class. Let's take a look at method 3. We have here a non-nullable string of non-nullable array of non-nullable strings. And this now printed also to the console a not null array of not null strings. And with that, you could analyze, you could utilize this nullability information at runtime. Problem is native AOT. Native AOT usually makes reflection hard or even impossible because some of the information may be stripped. So how can we utilize this at compile time? Well, before we do, I actually wanted to show a runtime feature when it comes to JSON serialization. When it comes to JSON serialization, we can configure this to respect nullable annotations. I set this to true to now make serialization and deserialization fail if I violate the nullability contract. This is just the basic, just a bit of an enhanced version of the web API to-do sample. And what I did is I marked the title as not nullable. The message may be null. So if we run this web app, we can also use the amazing HTTP file to quickly have an HTTP client at our hand to ask to do requests against this web API. Well, we can get some basic information like hello.net.amsterdam. We can create a new item. Succeeded. If I would set the title to null, now I'm violating the nullable contract, and I said that the nullable annotations should be respected. So this will now fail at, there it is. This will now fail at runtime bad request because deserialization fails without adding any validators. You could also add your custom validators to prove, to check against the nullable contracts as well. But if you want to do it on a deserialization level, this works as well. Well, the message is annotated as not null. So if I do set the title to not null, message may be null, but it's still okay, but because it's nullable. Cool. Now I mentioned native AOT or potentially problems at runtime. How do we analyze this ourselves at compile time? Now, we were talking previously about analyzers. So yeah, I'm always trying to build analyzers and mix them into presentations. This is actually a real-world example that I built at a former company I've been in. And something similar, we use data contract a lot. And we use data members. And there is required property on these attributes. And we wanted to say if something is marked as is required, then the nullable annotation should match. Is it required? It should be not nullable. If it's not required, it should be nullable. If I would now violate this contract, for example, is required is true, but set it to nullable, we get a warning. This is not a standard warning from the 1,600 inspection that we have. This is a custom analyzer that is now producing this warning. As well, there is not with the 1.5K quick fixes. We can add our own quick fix to now change the nullability. I hit return, and it fixes the code for me. I love Alt-Enter. We can take a look at the example, null aware contracts analyzer. I'm not going too deep into the weeds of an analyzer. It's a bit of an involved programming model. It's a diagnostic analyzer that works for C#. We declare a bunch of IDs. We say this works for classes, structs, and records. Now we analyze the nullable context options. Again, it looks very similar. We have 0 is disabled or oblivious. We have 1 for only warnings are enabled for the entire project. 2 for annotations are enabled for the entire project. Or free for both annotations and warnings. This is when we say nullable enable, we have the free. When we say nullable annotations on a project level, we get the 2, and so on. Then we check, does this type implement the data contract attribute? We check, does the property annotated with the data member attribute? And if it is, we now check its nullable annotations. So if the data contract is not required, but the annotation is not annotated, again, this is the very same structure that we see all over the place. 0 is null or oblivious. 1 means not annotated, not null. 2 means annotated, question mark, maybe null. So if it's not required, but it's not annotated, it should be annotated because it is a question mark, we report a diagnostic, and the other way around. If it is required, but has an annotation, that means it's required but has a question mark, that's also wrong, so report as well. And similar, we can also have a nullable fixer. So this is a so-called code fixer that works for this specific diagnostic ID, where we now add to the syntax tree a new node, the nullable type syntax. This is more or less just adding a question mark. That's a node in the syntax tree. If you want to inspect the nullable syntax tree, or a syntax tree in general, you can also use Writer to take a look at the syntax tree visualizer. And maybe we just focus in on this property here. And here we see the nullable type, which is basically just a node in the tree saying this is a question mark. Cool. And with that, we can also build compile time tools that check for nullability if we can't do it quite at one time. I mentioned the static flow analysis previously already. Maybe we have enough steps back to go to the previous example of our class. The thing is, let's get rid of most of the code that we won't need, just to make the example as simple as possible. Now, here we get a warning because this required, this not annotated string is not set. Well, I could set it via constructor, or maybe just here to make sure it's not null, to make the warning go away. And we also get a warning here, because this is actually annotated. What if we was to change this to a struct? We see in a struct, although the required property is not annotated, so this is not nullable, we no longer get the warning that we had before. Changing it back to a class, we see there is no constructor setting it. We also don't set it here. So actually, when creating a new class, a new instance, this required not null string is not set, therefore null, violating the nullable contract. With a struct, we don't have the warnings. That's because you can always just default a struct. Even if we had a constructor, and in this constructor we set the required string to something, if we now access this required string and the length of it, if we run this, do you think this is gonna work, or does this throw a null reference exception? Null reference exceptions? 1, 2, 3, 4, 5. It works just fine. 2, 3. Okay. The majority is correct. This will, if I would not fire up the web API, but here our console app, we will run into a null reference exception. Because the default, when you default a struct, no constructor is invoked. We just create this value type, set all of its field. Well, we have 2 properties that are backed by backing fields, all to the default. For reference types, they are null, so it will be just null. And because for structs, this will be very noisy, because for structs, basically, you cannot disable this default. Because it always has a value, even though previously we couldn't have a default constructor, now we can, but you can still with default just omit it. Well, if I would invoke the constructor with new, Now this is actually an empty string, and we should get 0 to the console. There it is. But a value type, we can always just default initialize. And .NET or the compiler team decided not to produce warnings because basically, well, when you have a reference type in a struct, it can always be null. You can't really prevent this. Definitely, yeah. Another warning that we don't get is when it comes to arrays. Let's say we have a string array, and we initialize a new string array of size 100. Well, it's a non-nullable string, a non-nullable array of non-nullable strings. If I were to assign it to null, you of course get the warning. I initialize it now to size 100, but we don't get any warning. What if we now for each over this array, over each element, and again do the trick or our pattern of accessing the length, dereferencing the string here? Will this work? I don't see any hands. Will this not work? I see not all hands, but significantly more. And indeed, we will run again in a null reference exception, but we don't get any warning. Because there isn't really a hook where the analysis can't really define that all of the 100 elements in this array are really set. So we don't get any warnings here. So with structs and arrays, you need to be aware of that. You may not get a warning. You need to be aware of this behavior. We were talking about null checks already, because if we have a string that is nullable, and if we were to try to dereference the string, usually its length, we get a warning here, and we can just surround it with is not null check, and the warning disappears because we are now safe. There is multiple ways of checking for null. We could also use the more advanced or the more modern patterns like is null and is not null. Now I would like, there is also more constructs like a null conditional. So we could, with a null conditional operator, we could set a question mark here. Warning disappears because the length is only dereferenced if it's not null. It's essentially the same code that I heard earlier with the is not null check before. We can also do something like a null coalescing operator, maybe say, well, if this is null, if the left-hand operation is evaluating to null, which in this case it is, because we are null here, we could then evaluate the right-hand expression. Well, it is a length, so it should be something. And so the right-hand expression is only evaluated if the left-hand expression is null. And another feature that is about nullability, we could also use the null coalescing assignment. So we could say question mark equals to something, which now means only if the text here is null, we assign something. If it's not null, else. Now, Python is already smart enough to statically analyze it, that, yeah, this is never executed because text is not null. The right-hand expression will not be executed and not be reassigned. So this will be else. When it comes to null checking, there is a difference between a null check and a true null check. Well, in here, I have a little test. We see this test is failing. Why is this test failing? I initialize here a class, and I check if this class is not null. I then do the same here below, but I'm upcasting this instance to object. This test is failing with a not implemented exception. How can a null check not be implemented? Well, actually, when we hover this, we see there is an operator. In this my class, I actually overloaded the equality and unequality operators and said not implemented exception. So if we say equals null and not equals null, and the operators are overloaded, now these are actually evaluated. So we need to make sure that if we have a reference type and we implement those, anything with equality eventually need to do a proper null check, because the compiler assumes when you say equals null or not equals null, that this is a null check, but it may depend on the implementation. If the implementation does something wrong, then the nullability gets messed up. However, this test, although being the same instance and the same operator, does not fail because we upcast it to object. And when you cast something to object, you do a true null check without actually invoking the operator. And one cool feature is that Wider visualizes it. If we see this has the same color as a method, that means we invoke the operator from the user-defined overloaded operator. But down here, it has the same color as the variable. So this is just a reference check against null. And when we take a peek at the IL code, we also see this difference. If we click in here, we see that we call the inequality operator. So this is, hopefully the inequality operator is implemented correctly, but this is not a true null check. Down here, where we upcast this class to object and then assign it to null, it actually is no op, because the compiler is smart enough to understand that nothing is really done here. So let me write this a little bit more evolved to string. Let's recompile that we get the new IL code analyzed. And we will now see that this here is a true null check, because, well, we load the instance, we load null, and then compare them against each other. So there is no operator involved here. Same is, well, this looks kind of weird if you upcast something to object. What you could do instead is use the is not null pattern matching. And this is also circumventing any potentially overloaded operator. It is doing the true null check. So when you check for null, use the newer language features because they are always correct. Now, I mentioned earlier that there is when you have a value type question mark and a reference type question mark, the significant difference, because the value type question mark is a whole new type, so that has an effect at runtime. The string question mark just gets some attributes, so that doesn't really have a one-time effect unless we write some custom code that analyzes this reflection. But there is a significant difference between an int question mark and a string question mark, because one is a different type, one is just compiler annotations. So when it comes to generics, it can get a little bit tricky. So we got more tools to define nullability. I have here an unconstrained generic. So any T is allowed. Well, that means really any. We can have a value type. We can have a nullable value type. We can have a nullable reference type and a non-nullable reference type. And we have a non-nullable reference type, and we try to assign null here, we get the warning as expected. Now let's take a look at some constraints. We can say, since C#8, we can apply the not null constraint. This now means anything that is not null. That is both a nullable value type. If I use int question mark, we get a warning. This the constraint is violated. And same with a string question mark, nullable reference type violates the not null constraint. Then we get a warning. If I make it non-nullable, everything is great. When it comes to classes, when we constrain against a class, that's basically allowing any reference type. We can say, when we say just class, this means a non-nullable class, not annotated. When it says a class question mark, that means a nullable reference type, annotated. So with the not null class, we cannot use a question mark. We get a warning. With the maybe null class, we actually can, but not necessarily have to. Another constraint is the struct constraint. That means any value type. This forbids nullable value types. So we can use int, but we can't use int question mark. One example is dictionary. When you use because dictionary based on hashes, when we would have a key that is null and try to get the hash code of something that is null, well, we run into problems. Therefore, the key must not be null. The value may be null, but the key cannot. So if we write a question mark here, we get a warning. Same with a reference type. And this is because the dictionary's key is annotated with not null. Because at runtime, if we would run this with a null key, we would get a null reference exception. Now, with generics, it can get quite convoluted. So there is a bunch of additional attributes that we can guide the compiler to do the right thing. There is a lot. If you search for nullable attributes, you will find this list. I just want to highlight 2 of them to give some idea what those additional attributes can do to guide nullability even further. We go to nullable attributes. Earlier I mentioned there's a difference between read and write state. Well, if we just have a property like this means both the getter and the setter are not nullable. But what if my implementation actually says, well, we return a string that shouldn't be null, but when we set a string that is null with the null coalescing operator, if this is null, we actually want it to be set to empty. In other words, this string, we allowing null to be set, but when we get it, it will never be null because we ensure that it isn't. But in here, we still get a warning when we try to assign null to it. In order to separate the read state from the write state, we could say, please allow null, which now means we are actually allowed to set null to it, but it's ensured that it never returns null. But again, we could lie. If I remove this check here, we are now lying to the compiler. We don't get any warning here. So be careful with these attributes. Another interesting use case is when it comes to constructors. I mentioned that this code analysis is static. It doesn't flow into any methods. So in this constructor, we call the initialize method. And the initialize method is actually setting the value to something that is not null because it flows through to the value, setting this to not null, and this annotated as not null to fulfill the contract. But we still get a warning that this underscore value is not set because the compiler doesn't dynamically flow all the invocations. So again, we can help the compiler by adding the, we need to add it on the method, on the constructor. We can help the compiler and say, hey, this when this method is invoked, these members are not null. So let's pass a name of to the value. Well, we could also use just string, but to make it refactoring safe, I like to use the name of. And now we tell the compiler after this method is invoked, value will not be null. To help the flow analysis decide, initialize is called, not null. If initialize is not called, well, warning comes back. But again, don't lie the compiler. If I remove this, we don't get any warning here. Well, we get a warning here because it's never set. So maybe let's do a different lie. Let's set it to null, but suppress the warning. We don't have any warning, but we essentially lied to the compiler. By the way, if you're on .NET Standard, all of these attributes are not available. You can polyfill this attribute. More modern versions of the compiler. So you can have lower target frameworks like .NET Standard 2.0, but with a higher language version, C#13. Not all of the features work, but most of the features work. But you won't have these nullable attributes available. But you can polyfill them by either placing them as internal types into your assembly yourself, or use some polyfill library like polyfill or polysharp. To come to a close, when we enable nullable reference types, do we still need to check for null? Well, it depends, of course. Let's say I am having a public static class. This may be a method. This may be in some type, in some library. And let it accept a value. If this is in, let's say, an executable, a desktop application, a web application, any executable, because usually an executable doesn't depend on another executable. Well, it can, but it shouldn't. This kind of terminal, it's 100% under your control. If all of the libraries that you use are null annotated, after years now since the feature is out, most of the libraries are annotated. All of the Microsoft DCL and such is annotated. All of the modern frameworks and libraries that we use are all annotated. So usually it's harder these days to find an older library that's not annotated. You can actually omit these checks because you can, to most degree, rely on the compiler with the warnings to never run into any null reference exceptions. When it comes to a library that is only consumed in your executable, like some local library that is only used for this project because you wanted to have some separations and make more use of incremental compilation. You know the consumer, and you know the consumer has nullable reference types enabled. You still don't necessarily need to do null checks because you can rely on the compiler. What if this library is public? If you share this on some NuGet feed, for example, an internal NuGet feed or a public NuGet feed like nuget.org, you don't necessarily own a consumer. And the consumer could say nullable disable or be on a net standard 2.0 project, which per default has a language version of C# 7.3, which does not have nullable reference types. So they just don't know about it. And when you cannot control your consumer, you should still do good old argument validations. Like these days, it's super simple with an argument null exception dot throw if null, pass it in. There is a diagnostic that you can enable that gives you a warning if you have any public member that doesn't validate its arguments against null. Because if you don't know the consumer could have it disabled and to still avoid null reference exceptions, and instead then throw an argument null exception to indicate to the developer you made a mistake here, better enable null reference types. For the final act, I would like to show you some alternatives to null. Is there a way to avoid null in the first place? Well, there is the so-called null object pattern. With the null object pattern, we design our types to be basically to not allow any nulls, but still do nothing because null shouldn't really do anything. So for example, the Microsoft Extensions logger interface, we can implement a null logger. How do we implement something that doesn't do anything? Well, is it enabled? No, it's not. Should it log anything? It's a void returning method. Just don't do anything. It's a null object. It does nothing. What about methods that return something? Well, we want to avoid null, so we definitely don't want to return null. So let's return again an instance of something that is another null object. Now having a null disposable that implements the disposable interface, and in the dispose method again does nothing. So although this type does nothing, or an instance of this type does nothing, we still don't have anything with nulls. Usually when you create a null object, since a null object doesn't really have any state, it does nothing, you can optimize it to avoid creating several instances on the heap that all do nothing and are the same and don't have any state. You can use the singleton pattern. This really is, you see this very often with null objects, where you just get this null instance, doesn't have any state, you can reuse it because it does absolutely nothing. And the second alternative, we already saw something like optionals. Well, similar to the nullable value type, the thing about the nullable value type, nullable of t, it is constrained to only work on structs. But we could design our own nullable. This is actually the nullable that is used by the .NET compiler team, which looks very similar to the nullable value type. It has a value, but it's unconstrained, so it could also be a reference type. And we need to check. We have a has value property, and before accessing it, you always do a has value check before actually accessing the value to avoid nulls. Cool. I will just briefly browse through my notes if I forgot anything. significant. I believe we covered all I wanted to cover. So I am now jumping to and QR code. This will go to my GitHub profile where I list all of my socials. If there's anything that I haven't answered today about nothing, or I'm not able to answer right now. So maybe we can open the floor for a few questions if there are some.
About the deserialization from JSON, for example, is there a way to know which property the deserializer didn't like, so that I can return a nice message to a client?
No, because it's already happening on a deserialization level. If you want to return a nice message, then you are required to use validators that are before the serialization and deserialization that are designed to create proper user-facing values. So yeah, that's actually a fair question. So if it's for an internal API, I guess on the deserialization level would suffice. If it's for a public-facing API, then it's a good habit, practice to return nice error messages, and for that you need validation.
Thanks.
Thanks for the talk, first of all. Then the question about actually throwing argument exceptions if something is not. Yeah. Two things I can think of, because it's still kind of tedious to add those to the code. So is there either a good analyzer that would inform me when I don't have those guards for public members, let's say? Maybe that's configurable. Or I also remember there was something in Fody which automatically generates those, but I've been, a bit out of touch with both of those, because you just reminded me that this is still relevant for users if they don't, have a nullable enabled.
Yeah. There is a diagnostic. This is not enabled per default. What I usually like to do in my projects, I go in a directory.build.props in the root of the project. So every C# project gets the same rules. And then I say, well, you can set the analysis level, which is usually defined per default by the target framework you're targeting. But I want to be them disjoint. I want to be explicit. So I set here the value of net 9. In 2 weeks, I need to increment this to a 10. And then there is different analysis modes. There's exhaustive documentation on that. And I see all. So all means most. It's actually not all, but a significant portion of the Roslyn analyzers. This is disjoint from ReSharper's inspections are now enabled. And one of these that are now disabled, because I will get them all over the place in my demo, is CA 1062, validate arguments of public methods. If I am now, well, actually, you could say this is an error, or if I omit it, the default will be a warning. Now, if we jump back to well, I should get a bunch of warnings. Let's jump to a library. Here's a library. This library is null annotated. And if I were to go, well, to our null logger, let's see if it actually does work. Let's create a public static void method that takes some string. We should get prompted with the warning, which of course now is should. Famous last words. I would expect this now to, did I do something wrong? Net 9, all enabled. I don't have any other rule. Maybe I have something other suppressed. But yeah, I explicitly disabled it for this demo because I was getting it all over the place. What about instance methods? Oh, I guess I need to use it, right?
I think here it's ReSharper disable all, maybe.
Could be. Oh, no, but that's the. Oh, there we go. Okay, I actually need to. I didn't know. I thought it's just by default. I need to dereference it actually, just using it also because this still can throw. But when I dereference it at the first usage, I now get CO1062, externable visible method. validate value not be null, and I think there should be a, there isn't. Well, there is no Roslyn analyzer, but there is a resharper. Oh, no, this is actually checking it. Assert expression is not null. Oh, that's a debug assert. Yeah, okay, so in this case, we now can say argument null exception dot throw if null.
You can try on the parameter, I think.
I can try, ooh,
I believe so.
check parameter for null. Okay, and then I can switch to the argument not null. Okay, there we go, 2 times Alt Enter. And this works because throw if null is annotated. This wouldn't just work out of the blue. It's annotated with not null. This not null is one of those many attributes saying, well, it ensures that whatever we pass in is not null. If it is null, well, before an exception. And this is now, so not only is the diagnostic suppressed, but also if I were to say null here, without this throw if null, we would get the warning here because we set it to null here. But with this warning, because it's annotated with not null, the compiler understands or ensures whatever we pass in here is not null. So the flow analysis later on stops and we don't get any warning here because we will actually have thrown here already. The second question about something with Fody, I can't recall. There is a NuGet package that you just include in your project. Not even sure if you need to set some properly. Just include it, and then it automatically, for every public member, then basically emits something like that for you because it rewrites with IL weaving. It rewrites your code. I am actually. It's been a while since I used this. I should have it somewhere in my crops. Do I? Maybe in the. Otherwise, I can take a look at it later and we can get back to it. Do I find Fody? Not sure where I got this. Let's check. I got it in the packages props. No, I'm actually not using that, but there is something that you just include and then it does that. Yeah. I tried it once. It worked. But yeah, I'm not sure how well this then works with nullable, with the rest of the nullable annotations pipeline and such. But there is something that just does it automatically. Yeah.
Okay, thanks.
Thank you.
Well, I want to thank you as well for
Oh,
presenting. I have some chocolate for you as well.
Thank you. Well, actually, I would also say thank you. First of all, thank you so much for having me. It's exciting to be in Amsterdam. Thank you so much for everybody watching online and being live here with me on stage. Thank you, Matthias, for sharing the stage with me. This has been amazing. And I want to say a very special thank you to the JetBrains team because I'm using your tools quite a bit. And I want to say thank you with an anecdote. With a friend of mine quite some time ago, we were discussing all of the patterns and practices that we have as developer, and it's a lot. And then he mentioned to me the most important practice that you can, the most important pattern that you can adopt, it's the alt return pattern. You just write a bunch of code. Well, these days you let generate by some machinery, and then hit alt enter as long as you can, and then check it in. Thank you, well, tot ziens.